Hi, so this time we are going to discuss the propagation delay test on an NImyRIO and how to do a propagation delay test on an NImyRIO and what are the constraints in doing a propagation delay test on an NImyRIO. So as discussed, the DUT we are using is the 74ACT11008N, and if we go at the data sheet for this particular DUT, we can see that the typical values for propagation delay is in nanoseconds. Now, in order to perform the propagation delay test, the basic logic is to switch the particular output of this particular DUT at VOH and VOL level, and just to observe what kind of time delays that we need or that we observe during the low to high transition and the high to low transition, and that is what we are going to do. So this is one of the tests which I had done. I'll just close this, and this is, so if I close this, so once I've connected, this is the main window that you get once we connect the NImyRIO at one of the computer ports. And if I click that the project which was under discussion, the functionality project which we had done earlier is the one for VOH and VOL. We'll be using the same one, but the only difference over here is we need to give specific iterations. So let's say I give 10 iterations and I'll give a particular VCC value, and if I'll turn this switches, this input ports on, I should be getting a corresponding output. And what I'll do is, instead of running it once, I'll run it continuously in this case. So once I click at run continuously, it will develop the code at the NImyRIO, and once the code is developed, we can see that the voltage starts building up gradually and it reaches at a constant voltage at 5.45. Once it reaches at that particular voltage level, we can just close one of the inputs. We can see the drop down to VOL level, and then it starts building up once again. If I switch the input to high, and you can see it is again constant at 5.45. I drop it down once again. I do this repeatedly and just ensure that it is reaching at its VOH level of 5.45 all the time. So once it reaches at 5.45, you can just drop it down by switching off the input to. This is the way wherein you can, I'll just stop this code now. This is the way wherein you can get this kind of transitions from VOH to VOL and back to VOH. And this kind of curve, as you can see over here, is nothing but the delay which is caused while taking up the measurements. This delay can be possibly caused not only because there is a delay involved in switching at the IC level, but NImyRIO has limitations on the sampling rate, and the amount of samples which are generated in particular second will also affect such a kind of propagation delay. So an approximate delay values will be obtained through an NImyRIO as compared to a precise bench equipment observation. But what we can do is we can get a ballpark estimation on what kind of delay values we have. So I already have a particular table or Excel sheet which I had generated for previous experiments on propagation delay. I'll simply copy this table because this is something which is required to us. I'll paste it over here and I'll just format it a little. Just a minute. Alright, so this is formatted now. What my main concern is, I'll just look for a value with 5.45. I can see a 5.49 here, which is the closest approximation to 5.45. So my VOH, so at 11.53, my VOH is my output is at VOH. So I need to see a particular drop down from VOH to VOL, which I can see at line number 156. So at 13.21, I can see that my VOH has been dropped to VOL. I'll just copy this timestamp over here. This is for high to low. Now I'm supposed to look at low to high. So this was at, so I saw VOH at 150. So 157. So now I will go and search for a VOL to VOH transition. And as I can see that at line number 326, it is minus 0.01, which is roughly a VOL value. And let me monitor it until it reaches to 5.45. So let me see where it reaches to 5.45, and the closest value for 5.45 is reached at line number 457. So I'll copy this entire data over here, and what I'll do is I'm concerned in this particular line and at the last line, this particular line. So I need to delete the data in between. So I will simply select all this, I'll delete it, and I'll also cut paste this data over here. What I've done is I have just pinpointed the high to low transition and the low to high transition over here. I'll copy this timestamps. Okay, sorry, so there is some kind of correction in the table. This should have come here and this should have gone there, and this is the voltage level which we are talking, so this should have gone here. Anyways, so I can just copy this timestamps here and I can format them into number, and I need to get a precise timestamp value so that I can subtract it and I can get the time difference. So I'm going to increase the number of decimal places up to more than 10 or up to 15. So as you can see, after 11th decimal place, it all is 0. So you can keep it to 11th or you can just keep it to 15, which is fine. And if I keep it to 15, my propagation delay is nothing but subtraction of the higher timestamp minus the lower timestamp. That is, I'm going to put this formula here, this minus this, and this is the timestamp, this is the propagation delay for high to low transition, and similarly for low to high transition, this is the propagation low to high transition, this is the propagation delay. I'll convert this particular column into scientific so that we can appreciate what is the exact 3 decimal places, what is the exact propagation delay. So for high to low transition, it is really quick, around 11.5 microseconds, and low to high transition, it is relatively slow, it is as low as 1 millisecond. Ideally this is not the value, but the reason why this takes place is the sampling rate of NImyRIO. So I'll take you to this particular slide which I have prepared. NImyRIO, if you compare the datasheet for NImyRIO, it says that NImyRIO has a sampling rate of 500 kilosamples per second. If you emphasize over here, it has a rate of 500 kilosamples per second. Similarly, the available bench equipments or model instruments in the PSP lab, if we check at the PXI 4141, it says that it has a sampling rate of 600 kilosamples per second. Whereas the bench equipment oscilloscope has a sampling rate of 20 gigasamples per second, which is really huge. And if you do the mathematics, it shows that I have just made some kind of simplified calculations. NImyRIO has a sampling period of 2 microseconds. PXI 4141 has a sampling period of 1.67 microseconds, whereas the bench equipment, the MSO 9254A oscilloscope, has a period of 50 picoseconds. And if we see the datasheet value once again, we are dealing with nanosecond values for propagation delay. So it is apparent on one particular fact that whatever delay values that you are seeing over here, so let me just go back, whatever delay values which you are seeing over here in microseconds and milliseconds are just an arbitrary approximation, or it is an arbitrary value provided by the NImyRIO just to make things simple and to understand what kind of propagation delay is available. However, this is not the exact value, but this particular experiment can be performed to appreciate how a propagation delay works out on a particular digital IC or a particular integrated circuit chip. So this is one of the limitations, but you can definitely perform this experiment to understand how propagation delay works. And that's it from me right now. Thank you very much for watching this video.